All right, good morning, everyone. Thank you for coming to this session. And you want to listen to me talking about Flutter engineering. Of course, it's a big topic. I don't think we can cover everything in 40 minutes, but I handpicked a few things which is related to architecture, and also two of the architecture that you probably have not heard about it unless you've read the book already, my book, The Flutter Engineering. Otherwise, it's going to be quite new for you and hopefully also interesting. So it's a bit of theory in the beginning, like a couple of minutes, and then we're going to do some slides as architects usually do, like they do the boringest thing, right? They show slides, they say this is great, and they are excited for their slides, as I am. And hopefully after that, I show you some code and make you excited with that. So let's get started right now. When I was writing the book, Flutter Engineering, and doing Flutter for like the last 5-6 years, I feel like there are 4 pillars when it comes to building an app with Flutter. And typically this is also a general things for software, building a software, right? And to my opinion, so 2 of them usually stand out more, and that's the user experience, which as a developer, as well as those who are, now we are building the app for them, our users, we have both good experience in this case. And one of the things that, well, again, applies to any software engineering, or building application, it's the trade-off. We get to this part a bit more after some slides, but just wanted to point out the pillars. Like, you're always dealing with time, like the deadlines. So you're always dealing with like, okay, now we've done a few pages, we're gonna scale. Now the state management I chose, it doesn't work. Then I need to do something else, This question comes up. And then you do something with one state management. In the beginning, you're super excited. After a few days, you said, doesn't work. We want to change again. So these are the things that typically in architecture, like in the beginning of building an app, you want to think about it. That's a concept in software engineering that we call it shifting left. Are you familiar with the shifting left? I mapped it to the Flutter journey, like building an app. What it means as a general, a software engineering shifting left or an architecture perspective in Flutter. So you want to move things a little bit ahead to the design part and before even development start, because that's where everything is cheap to iterate over. When you move around, when you go and deploy that to production and to the user, it's going to be much harder. And I guess that's one of the reasons that architecture of an app or software typically becomes an important thing. Even though sometimes it's boring, even though you get the boring answer, it depends, right? It still is an important thing because you want to avoid the cost that it comes afterwards. And the architects are cool people like me. They're sitting usually in a room, depends on your company. From top down, they decide things that they never probably spoke to developers down there for implementation, and they come up with a very nice architecture, and they want you to build it. And that's what I want to talk about today. It's not about, architecture is not about just these blueprints that we're going to build together, also learn how we do it. So it's more about building a culture in your company, in your team, and building a communication way, 2 ways between everyone, so that you can get feedback, you iterate, you come back, and you move on. But before I move on to the main part of the slides, let me introduce myself. For those who don't know me, my name is Majid. I am one of the Flutter community leads. I've been in Flutter with over a little bit of 5-6 years maybe. And I do a bunch of things for Flutter, like I did already Flutter Vikings and this conference and other conferences and books and articles and so on and so on and so on. But one of the things I did is this book that you've heard about it in the keynote as well. I'm not going to talk about my book, but one part of the book is about architecture, which I started like crafting that from a foundation. If you don't know software architecture at all, totally fine. You're good to go, reading the chapter. I don't know which chapter is that, but read the chapter foundation, and then you move on to the 2 different chapters. And I'm going to handpick some of the ideas from that, and especially from system pattern designs or architecture. When you're hearing about event-driven or microkernel or things like what really it means, and also how you can apply it to your application. Can you even apply that? So maybe yes, maybe not. That's what we are seeing today. But let's talk about software architecture. As I mentioned, so typically a software architect is about everything that matters. Everything that matters. Like literally is about your culture, it's about your design pattern decision, it's about the communication, it's about the technology that you want to choose, it's about different structure for your application, whether you want to go a different folder path, it's about document, it's all about all of these aspects. It's not one thing, it's not just about sitting and talking about layers. So, of course, it's the high-level things, but what I wanted to point out is that it's important that you establish a culture for architecting in your team, rather just talking about state management, which one is better, and how I make it into the layers. It's more than that. That's why in software architecture world, we have something called ADR, or Architecture Decision Record. Anyone has done ADR before? Fantastic, a few of them. That's what you do. You're gonna go and sit together and just write about the context that you're talking about, why you are making this decision. And at the end of this slide, you will see that in software architect, why is more important than how. You need to, as an architect, you need to answer about why I'm doing this, why that. And that's what I wanted to point out again from the Flutter engineering part. How well architected is this framework? There is a reason we love it. I picked up 2 slides or 3 slides for you to see how carefully everything is crafted, and they thought about the details before implementation. This is one of the charts of the book that I talked about, the rendering pipeline. If you go through these slides and the text, you will see like how carefully they designed, they separated the concern in this the pipeline. And that's why they can take out, at some point, a Skia and replace it with impeller. And that's why they can take out maybe a part of render object that is not working properly with another things. Here is another example of the rendering pipeline in more details. Piece by piece, thought about it carefully. And that's what I really like about Flutter. I talked about these pieces in detail in the book. So if you have the textbook, or some of you got the copy today, you can read about it, very detailed how these steps works. But what is important for me to point out is one of the main aspects of software architect, separation of concerns. And that's what we really carefully see in all of these aspects. And that also comes down even further, like it even goes to how well these objects should work in the program. So this is one of the examples, again, from Flutter directly, the render flex, how there is an object in Dart, then it gets to a render object, then you get a render box, then you get a render flex, and how each of these pieces are carefully crafted. So, but apart from all the details, which definitely we don't have to talk about it right now, we need to talk about one of the aspects of software architect, which is the blueprint of building the entire application. And I want to point out that Flutter, we all agree that in trees area, it shines pretty well. It's a reactive framework, it's a declarative framework. We love it because of these two. And also stream works pretty well because of well-designed in Dart. But why I'm saying this? Because it makes it the perfect scenario for choosing your architecture. What I want to point out here is that before even getting to what I need to go through for my application, you need to also pay attention for which framework you are designing an architect. You need to carefully think about, okay, I have actually stream under my power. I have actually the reactive part under my power. So then I can leverage this when it comes to going and designing an architect. So, and then when we talk about this, then we come to several different patterns and styles. I wanna say something here is that there is also two books that I will introduce at the end of the slides. And in these books, the authors are kind of promoting architecture styles are different from architecture patterns. And I kind of agree with that. Bear with me. And that means the architecture styles usually are very high level, while the patterns are a little bit more in details. Like you have the MVVM or MVU or these patterns, which are like a UI design patterns or architecture pattern, also emphasizes on different implementation detail. Whereas then you have the microkernel, where it's like a type of architect style, so that you can grab the style and then tweak it towards whatever pattern you want to build out of it. So we're going to talk about a couple of these in this slide quickly. I am pretty sure everyone in this room, just prove me that everyone knows layer architecture, or at least have heard about it. Almost everyone. And anyone else here in this room is doing anything rather than Flutter, backend, other front-end things. Okay, that sounds good. When we talk about architecture, so the architect usually think about the entire things, the entire pipeline of building. But does it mean that when you're going to design the architecture, you just need to, as a Flutter developer, think about the entire things? Probably not. You can actually apply that only to your application, but you can be inspired, and that's my point. There are different type of layer architecture styles, which goes to different patterns. Why I brought up layer architecture as the first and probably one of the fundamental of architecture style is just because when you go further, you will see that many things, including many patterns like MVVM, we get to that, are actually built on top of these styles. And that's why when I say a style are very high level, that's where it comes from. And this is one of the examples. Flutter itself is a layer architecture. It comes with different layers. It has the separation concerns, right? The layers where we are talking about doesn't necessarily need to name data layer or X layer or Y layer that we are usually or typically seeing that, right? It can be different name. But one of my favorite one, which I wanted to go through it, is three-layer architecture, which I've done it in multiple big and small applications, and it works pretty well. Sometimes for smaller applications, a bit like maybe complex, but sometimes easier to implement. And that's the three-layer of presentation, domain, and data, where you store everything related to presentation in your presentation layer, and the domain is everything related to the logic of your application, and the data is dealing with network requests. And everything related to the data object that you receive, different type of data that you're receiving, JSON, XML, whatever, it all be handled in that layer. So your domain and presentation layer, they don't know the API request, whether they receive JSON or something else. And they don't even care. So here is another thing that in architecture is important, and I want you to think about it when it comes to designing an architect, is the flow of your data, how that should work, and also the connection between each part of the architecture. So here is an example. Does it mean, I'm going to go through that in the live demo if you don't mind, so I'm just going to skip this slide for now, don't worry. I'm going to show this one first. We have a concept in layer architecture that we call it the closed layer and open layer. So you probably have seen many of these architectures that are going from top to bottom and mainly closed. That means you cannot go from presentation directly to data, and that's a good thing. This is a contract that we make in our architecture, and that's the way that you need to think about it. But does it mean it's the only approach? Absolutely not. There are always some reasons that you may want to open a layer and go from UI directly to other layers, bypassing this stuff. It just depends on your application. And that part, you can make it optional. So the point here is that not only you need to think about the piece of each layer and how they work, but also you need to make this contract between them and actually stick to that. That's where the implementation of the architecture becomes very important. In Flutter, though, usually these layers are a representative of the folder structure. I'm pretty sure you have done or already doing this in your application. You're making your folder structures, relaying on your architecture. So two approaches typically. We have the feature first, which typically means I'm going to have these three layers, all of them in one feature, which is a folder, and I'm going to represent that. Make it everything there. Is it a good approach? It's the bad approach. There is no good and bad. If there is one message in this talk is that there is no good and bad. It's just all depends. I think I invested in all depends maybe in the last 5 years many times. I repeat that. But so you need to decide which way is working for you better. Actually, I have a demo right now. It's a coding demo. I'm not going to do it now. I'm going to do it after the last slide. So go through the implementation detail as well so that you get an idea of how it works. Even I have a detailed implementation of a state management, and even I have an idea for you how you can replace that state management without actually changing too much of your code and have another state management. So bear with me for this demo. You get also the slides and also the source code of the demo. But before that, maybe you want to actually scan this. I'll come back to this slide anyway. But this is a full implementation of 3-layer with Riverpod and Firebase. Probably one of the popular stack that I've seen in Flutter community. But we get to that in a bit. I have 2 more, or at least 1 more demo, which is gonna be interesting to see. That's a little bit of promotion. I have also this in my website, Flutter Engineering IO, as a video. But let's get to the MVVM. So now, we talked about one style. We talked about the layers, the pieces, and how it works. And let's talk about one of the patterns. MVVM is pretty popular. So you have the concept of view model, and you know that model is going to deal with the data and the view is the presentation. What I wanted to say is that actually you can map this into a layer architecture. It's actually a layer architecture as well. It's inspired by a style. So when we talk about then MVVM, we can actually break it down to presentation layer, to the business layer, and to the model data layer. There are many more of these patterns. And each of them, when you open, they have a slight different because of a reason, because of different frameworks and community that they created them. But then at the end, when you look at the main aspect of all of the patterns, you see that it comes with that style of a layer architecture. And why I'm saying this is just because maybe sometimes in software architecture, you need to step or zoom out and look at this, the big picture, the pattern itself, the style itself, to learn more about it. Again, all of these patterns can also go to the folder structure in Flutter. That's typically what we do. The MVU actually is coming from an Elm community. Anyone has done Elm? No, I used to do I did also a lot of functional programming with Clojure, and I've been in those communities in the past, and a lot of these things also comes from there, where the concept of a side effect becomes very popular, in these kind of programming languages or communities. But I'm not going to talk about it. I just want to say again, when you look at this, you will see that, okay, so it's a type of communication, it's a type of pieces, but they all can be applied to a style of a layer architecture. If you know that well, you're definitely going to know this pretty quickly. So, but there are two more styles that I want to talk about. And I don't know if anyone here has done backend, especially in the style of event-driven, using with PubSub, or a stream, or event sourcing and stuff like that. But the idea of that, you're always gonna have, let's take one example of the event-driven. So one of the example in this case could be the Brooker style, the one on the left side. So event-driven architecture style, I think it's matching Flutter pretty well because it's focusing on streams. And that's one of the aspects of good characteristic of Flutter framework, which is applying streams everywhere. And you can get a pretty good responsive application with that. We'll get to some disadvantages and advantages after this, but that's where it comes from. So you have this idea of broker where you're going to have one central broker, that's one type. You have anywhere like all of your publishers, technically they're going to say, hey, get this event. The broker gets it, and there's multiple, probably, or maybe one subscriber or listener to that event. So you want to fire up or click on something, you just, on the action, you're just going to go and say, hey, get this click event. And then someone somewhere in some pages going to listen to that and react to this. Going to make this application pretty responsive and very loosely coupled. So let's take one example here. Let's imagine now we're going to have a user login event. Well, I'm going to go and log into my application. So this is a type of an event that I'm going to create in the sense of a class. Okay, so you need a broker here. So in this case, there is a package. You could also implement that. Actually, it's not a big deal. If you even look at the event bus, it's not a big implementation. You can even do that. But I wanted to use the package just to make it simpler in the slides. So you're going to have one, as I said, broker here, which is your event bus in this case. what happens? Then you have your login page or any other pages that you have the login. So the only thing that you need to do, you just need to tell the broker, I already fired up one event. And whatever event is that? Is the login event? Yes. Just going to fire it up. And I don't mind about anything else in that UI itself. And where you want to actually listen to that, you just need to have a subscriber. Just check on anywhere in your application that you want to have this subscriber and just react to the logic. As you can see, well, there are advantages and disadvantages. The implementation is pretty simple. But let's get to the advantages first. First thing first is that it's asynchronous completely, and it's also loosely coupled. So you can simply just go ahead and implement that without any worries. And as you can see, pretty flexible. You just need to define an event, and at any point, anywhere, you can listen to that event to react. You can have multiple subscribers as well, which makes it pretty responsive to your application. But there are disadvantages. Everything is a trade-off, right? So first of all, in 3 slides, it's super nice and simple. When you get it to your application, working with asynchronous programming, you all know this is going to be super complex at some point. Debugging is going to be very hard, and it's going to be a lot of overhead, like where this does come from. It's a bit of challenge in this case. Is it a good thing or a bad thing? It just depends. There's another style that I want to bring it up. I am right now working with a lot of enterprises. When I say enterprises, like they have crazy apps, big apps. So one of the problem in enterprises is, or even maybe in your team right now, is how can we make our teams autonomous? Or we want to develop an app. So, and maybe some teams, they have, these horizontal team that they are taking care of invoicing from the beginning to the end. And they want to actually have one part of it as like a feature in the app. So one way is that the way that we're doing that, right? We're going to go and just send it, pull requests or work on the app all together. Another way is, what if we can make this feature as a pluggable feature? And that's where this style comes from. And that's where I want to, again, emphasize on learning the style is going to be a good thing, gives you a lot of idea what you can do. And this is one of the ideas that we implemented in one of our enterprise applications. The main concept around it is that you will have a core where it's just handling the navigation, the theming, the base of your application, everything that is base, setting up everything that is needed. And the plugin. It's a pretty familiar style. I'm pretty sure many of you have seen this already. Anyone can recall where this style is very shiny and is actually implemented? Anywhere. Any system, operating system, any idea? Where? What? VS Code? Pretty much. Linux. It has a very tiny core, then you can just plug in. And even it works with just one hot restart. Sometimes you don't need to even restart. Can we take this into a Flutter application? Maybe? Let's see. This is my core. I've simplified for the slides, but I have an example you can open up afterwards. What it does is just scaffold my material app completely. And I want to have this plugin based on a route. Like when I change from one route to another route, that was one of the examples, so that we can have completely different feature. So I have now a plugin router, which is just generate the route on the fly. Well, let's take a look at the plugin routers. What it does is just register actually a route that you are passing through this generate function. So not a very fancy code here. It's a very simple logic. Just take a moment and take a look at what it does. It's just a few lines of code. Just register a map and just pass the route name to a list of route that the application can load. Now imagine I have a team that is working only on profile. The first thing they're gonna do, they're gonna make a plugin that is going to register their route. And that route is going to actually have their page. That's what we do in Flutter, don't we? And the rest of the things is happening there. Okay, that's very nice. I have another thing that is working on setting in this case. It's a different team doing the same thing. And now they're completely in different event repositories. They have their own environment set up because they wanted to work on, similarly. We'll talk about also the architecture of each of these teams, don't worry. But what it happens is that I can come back to my main, the core app, and I can just load up each of these profile or each of these plugins. I'm just gonna say, hey, load my profile or setting in this case. And I'm gonna quickly go and show you what happens then. So when I load my profile, so in this case it's true, I'm just gonna register the plugin. That route is gonna be registered, and same for here, my application. Nothing really fancy. But then I have two buttons here in the core of my system. So then when I click on go to profile, it actually goes to that plugin. If I disable it, it will actually become disabled and I cannot go there. I mean, I can prove you. I don't know if, let's see. Then next time, if I click on that, so I'm gonna get an error because that route is not registered anymore. And that plugin is completely independent. I mean, it's a simplified version at the moment, but you get the idea. This is one way of applying your architecture style that you know into a real application. Just now, we can make this as a package or something, and then each team can work independently. It could be a monorepo, it could be different. But what about the architecture of each of these plugins? But that's, again, is totally up to you. If you are going to use, if you want to have a set of layer architecture for these plugins, and you want to also enforce the teams to use that, that's up to you. If they need to use different things, that's, again, up to you. You want to let them to have different architecture, up to you. But typically, what you want to do, you want to make a general decision. You don't want to like them use block and then you use riverpod and another one use X and another one use Y. And so probably unification in this case is a good idea. So each of these plugins then goes through again to the architecture style that you are going to implement. So, but tell me, if you had this problem of making team a little bit independent in your company, who has this problem already? Sounds good. No one. No, a few people actually have, sorry. So, but again, that doesn't need to be a team problem. It could be something else. Maybe it's a package that you want to make it available to open source and at the same time use it yourself. And so many other things. Again, it comes with advantages and disadvantages. One of the points of the architecture is to make the application more modular. where you can work easier. So you can imagine that you're going to have also a common library that all of these plugins going to use anyway. You probably have plugins that have platform interface, they're going to use it, and so on and so forth. And of course, one of the maybe good the aspect of the architecture is the maintainability of that. There's also complexity around it. As it gets bigger and bigger and bigger, it makes it more complex. The overhead of having different completely isolated teams to work on their plugins, it can be at some time overkill. So you need to think about all of this before committing to making the style applicable to your application. And that's not only these styles, by the way. There are many more styles that may be relevant or may not be relevant to Flutter. But at the end, learning them, I guess, it gives you idea when the time comes, when the problem happens. All of us here are software engineers, and all of us here to solve problems. And it could be a problem in Flutter, and it could be a problem in anything else. We are solving problem in terms of building software. And I think this is important that you go through these architecture styles. And I think all software architects should know a little bit about that. You don't need to be expert, but you need to know. This concept of you need to know in architecture world is also very important. Probably you've seen the pyramid of things that you know is on top of the pyramid, and you're expert, you're all Flutter expert. There is also a layer that you need, there's a stuff that you know you don't know, and it's always to have that as wide as possible. And there's one layer down that there's millions of things that you don't know. But the architecture roles are like getting to this, while they're keeping their expertise, also getting to the middle layer where they try to learn, try to expose yourself to different things, read and learn. You don't need to be expert, you just need to know about it. And 2 points out of the slides. One, trades off. Please, after this talk, do not go and say, this is good, this is bad. There is no such a thing in software engineering. It just all depends. It's all trades off, even in our life. Everything has trades off. And to my opinion, architecture is an iterative approach. So you can make some decision because of the inputs that you receive, and at some point come back and iterate over it. The iterative architecture actually a thing right now. And the second one, as I mentioned in the beginning, and very important, is that you need to focus on why I need to do microkernel. Because I told you and it's cool, or because it's actually working for you. Or why I need to use Riverpod instead of X, or Y, or whatever. Before you get into how. If you can't answer the why, then you're going to have a better time moving towards shifting left and reducing the cost of implementation. And always remember, this is actually a story. I've worked with a lot of people in the architecture world, and they come to us or to me and they say, hey, look at this architecture we did. And they are super proud, and you look at it and say, wow, this is super complex. This is cool, of course, but super complex. And they have only 3 pages in the app. I said, okay, that's fantastic. But have you thought about this and this and this? How many people are you? 3. Okay. You want to maintain this super complex architecture? Yeah, of course. Okay. But then you start doing that because it's a trend, because it's why, because it's whatever else, and you start doing that. It's cool. Everyone uses Kubernetes these days. How many of you are using Kubernetes? And it's awesome, and you have only 3 Dockers. And so why? And you don't even need to scale to 100,000 people, and you're using Kubernetes. I mean, why? So you don't answer this question, you get to this problem that, okay, now we get to this, that our cost of maintaining this is quite high. Not only the cost of spending our engineer times on maintaining, but also the cost of the money that we pay to providers like cloud or whatever. So then, you need to think about as an architecture where we are effective and efficient. It could be very simple, and if it works, it works. Think about that. And one more thing is that there is, and I'm pretty sure everyone agree with that, more or less, there is no one-size-fits-all solution. And as I said, everything depends, right? So always think about that. And if you want to take a picture and read more about the software architecture styles and pattern, so I have 2 books for you. The first one, apart from my book, so there's 2 more. So first one, I recommend the fundamentals of software architecture. I recommend everyone read it. It's actually quite easy to read, maybe 300 pages, 400, and quickly go through the styles. And the other one, if you are serious about architecture, read that and realize why event-driven is actually quite complex and where is the hard part of it. And if you want to get the access to slides and sample codes and everything, here is the link. You get everything in your free time or spare time. Go ahead, look at the examples. I have a repository of Flutter engineering examples where you can get into many other examples as well, and you can take a look at that. And last slide is that if you won already a book, good for you. If you have the book already, good for you. If you like the type and you want to have the book, DCM is sponsoring 80% of the book, and you just need to pay 20% more and get the book, and maybe the videos, whatever. A little bit of promotion at the end, but I guess it's for good reason. So how many minutes I have? Because I have a demo I like to show. Anyone can tell me in this room from organizer part? How many? Okay. -4 is great. Have a great time and enjoy your conference. Meet me everywhere. If you have questions, please let me know.